Hello! In this video, I'll be going through the steps involved in solving a typical linear regression problem using StatCrunch. Given a dataset, we will draw a scatter diagram, and then find the correlation coefficient, the critical value for R, and the equation of the regression line. Then, using our regression line, we'll find the residual for a given value. Okay, so let's say you have a problem like this. The accompanying data represent the square footage and selling price in thousands of dollars for a random sample of homes for sale in a certain region. Part A wants us to draw a scatter diagram for this data. The first thing we need to do is open up our data in StatCrunch. We can make a scatter plot using the regression function under Stat, Regression, Simple Linear. Next, we need to select our x and y variables. In this question, we're interested in predicting the price of a home using its square footage. That means that square footage will be our explanatory or independent variable, also known as x. And since we are trying to predict selling price will be our dependent or response variable, which is our y. For now, we don't have to change anything else, so we just hit compute, and we have a results window. To find our scatter plot, we just click the arrow at the bottom of the results box. And there we go. We have a scatter plot with the regression line running through it. Next, for part B, we want to find the correlation coefficient R. Basically, we're being asked how strongly these two variables are related. So in order to find R, we just click the left arrow to get back to our original results box. And the correlation coefficient for R is the fifth item down. And so for this data set, R is about 0.903. And be sure to pay attention to how the question wants you to round your answer. Next, we want to know for part C, is there a linear relationship between these variables? Is square footage actually a good predictor for the selling price of a house? So in order to figure this out, we need to compare the absolute value of R to the critical value for this sample size. So first, let's find the critical value. If you're using MyStatLab, you'll be given a table of critical values for the correlation coefficient that looks something like this. And in order to find the critical value, we need to know how many observations there are in our dataset. For this, we had 12 observations, or 12 houses. This is our n in our new table. And the critical value associated with 12 is 0.576. Next, we take the absolute value of our correlation coefficient. Absolute value of R is equal to the absolute value of 0.903, which is just 0.903. Now, we compare the absolute value of R to the critical value. Since 0.903 is bigger than 0.576, we say that there is, in fact, a linear relationship between these variables. Okay, now for part D, we want to find the least squares regression line, treating square footage as the explanatory variable. Since we know that there's a linear relationship between these two variables, it makes sense to find the linear regression line for them. This is also found on our results screen. It's the third item down. And something to be aware of, some homework might want you to report the line in the form y hat equals mx plus b, but StatCrunch gives it to you in the form y equals b plus mx. So be sure to keep your slope and y-intercept straight when you're inputting answers. So here, for example, if we wanted our line reported in the y equals mx plus b form, rounded to 3 decimals, we would write y hat equals 159x plus 8.213. Alright, next we're asked to interpret the slope of the regression line. Many problems will ask you to also interpret the slope of your line, and there's a format to follow when answering. The basic format for a positive slope is, for every 1 unit of x increase in our x variable, we can expect a slope, units of y, increase in our y variable. So for our example, our answer here would be, for every 1 square foot increase in the square footage of a house, we can expect a $159,000 increase in the selling price of that house. Okay, so now we want to know, what is the predicted selling price of a home that is 1,433 square feet? So in order to find this predicted value by hand, we would have to plug the value 1433 into our regression equation and solve for y. However, StatCrunch will do this for us. We simply go to Options, Edit, to get back to our simple linear regression menu. And then now we find the section labeled Prediction of y. In the x values box, we enter our value of 1433 and then hit Compute again. Now on our results page, we have a new section at the bottom labeled Predicted Values. And the value we want for this question is here. Our predicted y, which is about 235.9 or 236. So for our question, the predicted value or the predicted selling price for a house that is 1,433 square feet is about $236,000. Okay, so for our final part, if we observe a 1,433 square foot house selling for $210,000, what is the residual of this value? And recall that residuals are found by subtracting the predicted value from the observed value. In other words, residual equals observed minus predicted. And we found our predicted value in the previous question, which was 236,000, and we know our observed value here is 210,000. That means our residual is simply 210 minus 236, which is equal to negative $26,000. Alright, so we have answered all parts of our question. I hope you found this video helpful. If you're a UNT student, there'll be some links to other resources in the video description. Thank you so much for watching.